All right, everybody, thank you for coming. There's 700% more people here than I thought there would be, so that's good. All right, so my name's Sean. I'm a technical artist. I'll get into that in a second. And this is what we're doing today, right? We're going over forward-looking. So a lot of this is more of a methodology with a little bit of a show and tell. What? Click your name. Oh, okay, here we go. Okay, so at Unreal Fest I did you're probably lighting wrong, so I thought we would continue on this trend. And again, as a caveat, this is kind of an overview forward-looking as opposed to like, you should do this. And the reason why I found a lot of environment artists are still thinking about hand poly modeling and going straight into ZBrush, and how does that work with art director and actually building out building out things in quick iteration. So we're going to go over excuse me, why this talk, where we have come from and where we're going. Can I make this bigger? There you go. Then we're going to define the problem, so thinking with data, not polygons. Then we're going to have a look at the tools pipeline, so developing tools for quick iteration. Then go through like destruction and how that works, detailing, surface detail, and then art direction. And I was going to do a demo, but when I did a run through of this, it was 54 minutes because I have 119 slides, so let's go. Why this talk? Where we're going and where we came from and where we're going. So in 1979, Asteroid came out, and it was vector graphics, and it was black and white. And then in 82, it was Robotron, so colors and sprites. And then 85, sprites, background layers, 4-bit pixels, so Super Mario Brothers. And then in 93, it was Doom, so now we got our first 2.5. Not first. Anybody who's been here in a while, and you're like, well, actually, just you know, just you know. So then in 96, there was Quake, and that was like fully 3D, right? And then 98 was Half-Life 1, so the skeletal mesh animation. And then 2004 was Doom 3, it's fully dynamic lighting, normal maps, specular maps. And then COD 2009. Then 2013, we had Crisis 3, which we even know now, if anyone watches Digital Foundry, it's like the new version of like, you know, but can it run Crisis, right? Because it still brings things to its knees sometimes, right? But here we saw larger environments, higher fidelity geometry, textures, materials, etc. And then 2018 with Red Dead Redemption 2, there's like biomes, atmospheric simulation, higher fidelity assets, and overall clutter. 2020, complex animations and materials and all that stuff with The Last of Us Part 2. And the Demon's Souls remake, which is really interesting comparison if you've played both. But they had some really good like global illumination you know, implementations, and the world geometry was like really, really high polygon counts and, you know, really dense, and it felt really solid. And then 2024, scanned assets for greater realism. And then, you know, Black Myth Wukong is kind of like used everything, and I think they used their own NVIDIA branch of Unreal or something like that. So we went from Asteroids to Doom 3 in 14 years, and then Asteroids to Doom 2, and then Doom 2 to Doom 3 was 11 years, and then 9 years, and then 7 years, and then 4 years. And in 1979, there was no concept of environment artist. In 2024, we have environment artist specialist for modeling, texturing, materials, foliage, road, terrain, EDC, you name it. Our medium is constantly evolving, and the definition of insert position here artist shouldn't be thought of as a definitive thing. Right? I'm an environment artist, therefore I open up Pick 3D program to hand model my extruding, beveling, knife edging, whatever. That's what we currently do, but looking ahead, what are we going to have to do, right? So define the problem. If you have a look at Grand Theft Auto 4 in 2008 and Grand Theft Auto 6 coming out potentially next year, And for the tech people out there, you could probably, correct me if I'm wrong, because I'm a tech artist. But I believe if you took Grand Theft Auto 6 and you deleted all but the high priority assets and replaced them with cubes, so you deleted all the high frequency detail and models, and you replaced everything with cubes, as well as remove all the expensive rendering features like PBR lighting, volumetrics, particles, weather simulations, etc. I'm almost positive it may run on a PlayStation 3. So the thing that I'm getting at, so for the actuallys out there, is that it's like the art side of things has just gotten exponentially complex, right? There's just so much to do. I'm not saying that the other sides haven't, so please put down your tomahawks. But if you have a look at Grand Theft Auto 4 on the left and Grand Theft Auto 6 on the right, the biggest difference between these two screenshots are rendering features, asset quality, and fidelity. Obviously, there's a lot of gameplay stuff and systems, but we are fast approaching the ability to create almost anything we want with total realism for consumers just around the corner. And I honestly believe that there's probably more polygon density and complexity in the first, 5 to 10 meters of the frame of GTA 6 than there is in all of GTA 4's frame, right? So you can kind of see what's happening. So almost all our environment texturing is done with tiling textures on relatively low polygon flat surfaces, like this gray wall on the left. The gray wall is 12 polygons, whilst the final in-game mesh on the right is 2.8 million polygons, right? So how do we effectively build an asset creation pipeline where we can quickly iterate and get approval during each phase of the process to remove as much uncertainty as possible? We all know the leads and the directors are like, but I want to see the finished asset. Or IP holders, right? So if you have a look at this kit that I made, it is 85 pieces totaling roughly 200 million polygons, okay? So if you were to sit there and make this, open up ZBrush and you're like, it's a nightmare, right? Because if you need to iterate, So not feasible to create 200 million polygon kit by hand, okay? So here you can see on the far left is the block mesh, and then we have roughing it out, and then we kind of add some destruction to it, and then we kind of add the final polished details. As mentioned previously, this mesh is 2.8 million polygons, although it was generated not hand sculpted. There's still quite a bit of approval before we even get to the final stage. And approval, I mean on your team, everything, right? Come on, buddy. Okay. So you can see over here, we also need, it's not only art direction and how do we build it, but it's also about working with design, because at the end of the day, it's about the game. We're making the game first. As we go, we need to check with design for collisions, sight lines, spatial updates. We need to have relatively fast iteration speeds in order to get approval to move on to the next stage. So this process really shines if you're building someone else's IP, as we can adapt to unforeseen external changes, right? If you can quickly go back to the block mesh stage, change things and then go back, but if it's I have to open up that ZBrush file and pull it down, oh my goodness. Yeah, somebody knows. So if you see here, we're also not talking about tiling textures, we're talking about tiling geometry. So you can't just have these kits and then just negatively scale them to stick it elsewhere, because if you have a look in hopefully you can see it, there's a piece right in front of us, a small piece. If you look to the left and right of that, they have to meet up perfectly, right? And you don't want to have to go and do your whole kit, and then someone's like, you know what, that's kind of weird. My my ticks are making it we need to change that, right? So all end caps need to be consistent. If changes need to be made, the more pieces, the bigger the job, as every piece will need to be updated. Sculpting each brick would take too long. This loops back to updating the joining bricks. Brick repetition, no brick is the same per asset. Hand authoring is a destructive process, so it's difficult to update at a later date. Okay, next. So, when we're building this piece, there's actually two pieces here, they're joined together. We have to look at the vertical brick count, the brick height, the brick length, the brick depth offset, wall length, brick tiling edge seed. Since it's tiling edge seed, this needs to be consistent across the whole kit, all right? And we can also do like initial R&D tests to show leads and directors how it's not feasible to get every piece. Oh, it's not feasible to get every piece built, so you can like just do it on one piece. Also, for this example, I did a ruin on purpose because sci-fi things are comparatively simple to make, right? And like environment, you know, those people on YouTube who are like, look at this thing I made in an hour. So I went to the Megastore assets, and you're like, but how do we make it, right? And sci-fi stuff it's comparatively easier. So I had some talks with people at work, and they looked at this and they're like, why don't you just use displacement maps? Why do you have to go through all of this? Well, we can use textures to displace the mesh either as a pre-process or at runtime. This can be a great option for surfaces without much displacement, like a brick texture, like small stuff. However, there are some downsides such as texture smearing. In most cases, can only support minimal displacement. Here's some extreme detail. So what do the tops and sides and the bottoms look like? Runtime displacement has a cost. Do we want or need to pay that cost? So even though we're going into this world where we have so much compute and the technology is so wonderful, we still need to optimize the heck out of everything because that means we're getting performance back, you know? I remember when when Unreal announced Nanite, I was kind of like, how are we going to start doing that? Like that's, you know, so there is a cost to all of this. So again, going back to displacement, runtime displacement or something like that, or even if you're going to displace offline, what happens if you need to take that kit piece and like blast a hole through it, all right? What happens, like, there's just so many things where it's like, so now, okay, we need to make another texture, and then we need to like cut it out, and then we need to, it's just a headache. So just make the thing, you have the data, okay? So building the tools pipeline, developing tools for quick iteration. So I'm not going to make this one, I'm going to make something very similar. And so the first thing we're doing is you obviously get the level design. And again, this is part of the process is level design. It's like it's, you know, almost always not on a grid if you need it on a grid. You know, things aren't like spaced correctly. You're like, why? They're like, I don't care. I'm just trying to look at gameplay. And you're like, yes, but now that we have to change it, does the gameplay work? Right? So you have to like figure all that out. And you kind of do it with, as we all know, block mesh, because it's cheap and easy. And once you've figured out your kit, I mean, we already do that. That's the first part of the process. Like, what are we building, right? So throughout this process, I've built a very basic tool set in Houdini to create this kit. And again, the reason why I'm doing it this way is because so many environment artists kind of look at Houdini and they get scared, right? But honestly, to you all, if you can use ZBrush, you can use anything, because that program is obtuse, okay? Also, if you can do game design and game development and environment art and whatnot, you can learn this stuff because think how abstract that is. Go to somebody who doesn't do it and say, right, so here's a normal map, and they're like, I don't know what the hell you're talking about, okay? So just you know, relatively speaking, right? So this is like a basic node tree. I'm gonna go through it, right? So I built it in Houdini. I'm sure this can be done in any node-based DCC package. I haven't tried it in Blender yet, but I would like to go down that road. So you can see we have brick height. So you just change a slider. It changes the height of the bricks, right? Sorry, on the left is the front of the wall, or the external part of the wall, and on the right is the interior of the wall. So here we're talking about brick length, right? So this is the cool part where you're sitting down with the concept artists and the art leads and directors, and you're like, well, how tall do you want the bricks? Well, how big do you want them, right? So this is the, did that miss one? Oh yeah, so brick depth, like how thick. Now the reason why I showed an external and an internal version of this is because what I tried to do when I was building this, going through this process, was I didn't want to like just mash geometry together. I wanted things to fit together because that's where we're going, right? That's the thing. So you can see in the right-hand side, those interior bits that's getting bigger or smaller. I also made this brick wall double brick, again, to add that extra complexity, because you don't want it to be the same on the inside and the outside where they meet up. So it needs to be different. How do you keep that seed the same? But as you can see, on this internal bit, I wanted the internal walls to be single brick. So when you increase the depth of these bricks, the bit which the internal wall butts into, scales to the same size. So it takes that extra layer of stuff off the table that you don't have to think about. Because once it's all set up, it's super fun to make the pieces, right? And then obviously brick depth offset, because if it's a ruin, like, well, how ruined do you want it? Do you want it this much ruined or this much? Well, I don't know. Well, can you make them your damn mind? And then obviously wall length, right? So this is you have your kit pieces, like how much do you want? Okay, so this is also another big one, brick tiling edge seed. So you can see the slightly gray one, that's like a small piece. And this goes across your whole kit. And when you set it up as you go, you can set up a parameter where you go to the top and you can like move it and your whole kit changes. It just propagates through everything. And the cool thing about all of this is because if you can harness this power, and I'm sure you're all amazing artists, you can now focus more energy on the bespoke stuff and let the computer do the boring, annoying stuff, right? That's why with all this AI stuff, I'm like, can you please solve UV mapping or like weight painting for like animation? Like none of this other nonsense. You don't need that, right? So let's go through it. So we start using block mesh as reference. So we just import one of those pieces. And then we pull in this wall brick node that I made. I'm not actually going to go deep into the nodes. I actually have resources, but it'll just take too much time. So we create this, right? And then like, okay, we want 8 brick heights, and then on the external brick we're working on, we can just lop off the bottom and do whatever we want. So you can see on the right-hand side there are those 2 columns of nodes. So the one that is piping into this node is the one on the left, so the ref base. And then the one on the top, so we can just add some accents. And that's really simple to do as well. You can just sit there and be like, what about this? What about this? And it doesn't take very long at all. I think once you get into the flow of this, like each piece can take like 10, 15 minutes, not even, like to make this. And then once it's made, you just screw around with sliders and, the pieces take, seconds, right? Then we want to bring them all together. Then we get the internal wall. We make those. We split off the bottom because I didn't want to have bricks going into the ground because that's weird. You want to have like one long like stone slab that goes into the ground because we're builders at the end of the day. Gotta get those protocols. And then we just kind of combine them, right? And it's at this stage again where you can like just play with those parameters and just see how things work, right? And then the brick offset. And then we're just adding a bit of a bevel just for this R&D stage to kind of go, okay, how this works, right? So this is it. You just like export that to Unreal and you're like, okay. And like this is an amazing conversation start. Like if you went through your whole kit and just like, okay, this piece, what about this? People who know how to use Houdini to some capacity, you just knock out bricks, pull things, it's like in Ratatouille, when Remy is like jumping over the pot, he's like, oh my God, some salt and some pepper and celery and all that kind of stuff. It's like, it's that fun. But Sean, what about materials? All right, so again, roughing out stage. Let's just create a diffuse map for like rock, dirt, and some lichen, okay? And then we're gonna make some vertex colors because we can to block out our material. Because as you're doing this, you should be able to do it for materials as well, right? So we just go to our mesh, we give it some, like this is it's like unwrap node here, please. And then the next most important thing is getting the correct texel density. So you go, okay, texel density, great, done. Then we want to subdivide it, just because, points are resolution. And then we make a black. And then on the other side, because we're working on the mortar, we're going to turn this into a VDB, which is a volume database to merge all the bricks into like a single like hull. And then we'll smooth it, turn it back into a mesh, blur the heck out of it, and then peak it, so like push it in on the normals. And then use that as a mask for internal point faces, okay? And then we can like expand that mask, and I'm gonna hold this thought, so expand that mask. But before we do anything more with that, I'm gonna run through a quick for loop and just say for every brick, give it a value of, in the blue channel, give it a random value between 0 and 1, okay? So we've done that. Going back to our expanded mask, we just say for all those pixels, points in that group, give it a red color, blur that. Then we want to get the bottom of our things, we just get those bricks, give it a green color, and then we merge them all together. Then you can export them into Unreal or bake it into a texture. I don't really care, do whatever you want, it's fine. So then I took those texture maps, and because again this is a an experimental project, I was like, let's see what's happening with substrate. And just very basic. You could do this with a current material pipeline. Just 3 texture maps all put in, right? And then, so this is that final result, right? So we have the red channel. So this is for the dirt or the mortar. So we just have our standard bricks, and we're putting our dirt on. Then we get the green channel because we want to add some variation to the base of the kit. So then we just like change the diffuse color, right? And then we have our blue. What you can also do here, which is really cool, is based on the position of this kit piece, you can get the world position and then adjust the colors of these blue things. So when you actually do tile it, the tiling doesn't, it's not repetitive too, because you can say, oh, the black one, I actually want it to be 0.5, and this one I want to be, so you can actually do stuff there, right? So many things to do. It's amazing. Then this is the color information, right, to add some variation. So you can see, and then we layer in the lichen, right? And so you can see, if I take that original kit piece, the final one, and we put this one in the center, we've done very little work to get to this level of quality. Creating more pieces now is fairly trivial across the whole kit. We've solved this, okay? So geometry tiling, shapes and size of bricks, providing the ability to add consistent decorative flair. In this case, to the top and the base. This is a great time to do a pass on as much of the kit as needed, and as making changes is very easy. And honestly, this can stay like this for quite a lot of development time. So lighters, material artists, designers, foliage, all those people can just like block in and do stuff, right? You can go pretty far with this. But now it's a ruin, we want destruction. Okay, cool. So we take that, excuse me, and we take out like the center pieces of bricks. We just go, okay, we want to do that. And you do that procedurally. You can get a box or you can delete them and whatever. And then we just run that through like a fracture node where it just like cracks it. We just get rid of like, edge breaking. And then we just merge it all together. Hopefully you can see it. There's just a little bit of breakage around. And that, again, it's incredibly easy to do that. Then we take all of those brick pieces and we kind of make constraints to them. So like, this is where you are. And then we kind of just run it through a basic simulation. I literally have balls on each side. I'm just like, go this way, bang. And then you just kind of like go, okay, which frame? So we're going through and we decide which frame we want, delete all the velocity, because if you get another like simulation node and you go play, everything will fling off because it still like stores the velocity per frame. So you delete all the velocity and then run it again through the simulation just for everything to just like settle. And you can see I've just taken the same kit piece and put them on either side so our tiling isn't moving, right? Because that's really, really, really important. And then we can just go through and do a time blend. So at what frame do we like the destruction the most? Oh, this frame. Too much, too little? I don't know. Maybe we can take frame 1 and frame 10 and like blend between that, right? And then we just like delete all the pieces that have fallen through. Then we do the divide and the vertex color like we did before. It's the same thing, and put it in Unreal. And you can see that on the left, closest to camera is the pre-destruction, and then the middle two ones are like the destructive pieces. And you can see it's like we've done most of the work, we're just adding to it. And even now, if somebody came to us in the, in leadership, whatever, and was like, hey, this is like too repetitive or too whatever. You're like, okay, well, what do you want? Or you can just say, you do it. So now detailing, surface detail and art direction. All right, so let's go rock detail. So this is arguably the most simplest and fun point, asterisk, depending on the speed of your computer. So what's happening here quickly is the yellow box around everything is something called a compile block. It just, the orange box is a for loop. So it's like if you have 10 bricks and you go to the top of the for loop, it goes, oh, brick 1, I'm going to do some stuff to this. And then it ends and it goes, oh, brick 2, I'm going to do some of this. But when you put that in a compile block, the yellow one, it goes, oh, all of these bricks, oh, I'll do this one. Oh, I have all of these CPU cores. Cool, I'll put them on as many cores as I can use so things go faster. So we start here with the basic, just one of the base brick pieces, and then we just turn it into a volume database, run a noise thingamajigger on it with some parameters that the art leads and the art director and everyone has gone, yeah, that one. Then we run I just ran a sharpen on it to get rid of some of the high frequency details because personally I wanted the texture maps to bring that through. And you just let it run. So this took 1 minute and 6 seconds, right? So if you have the whole pipeline, it's very quick to get this through. Now the mortar, this is more of the tricky stuff, right? So how do we do that? That was a long R&D process, but solved it now. So the first thing we want to do is take our brick wall, whatever, and we want to duplicate it on each side. So if you have it like this is your brick wall. You want to take it and move it to the end like this and delete everything but the sides that butt up to your original piece, and the same on the other side. You could make a tool which just does that automatically, right? And the reason why we want to do that is because you can make this really nice mortar, and then you get all your kit pieces and you put them together, you can just see these seams everywhere because there's no mortar between them, right? So we have to think about that. And then we get our generated high detail brick piece, and we run it through the system. Now, I wanted to go through this, but again, I ran out of time, but I have some resources for you, so, I got you, boo. So combine this process to create a watertight volume, right? Now, why? So you can see that, so this process actually took 21 seconds. Here you go, this is the thing, bang. Okay? But why, Sean? Why merge this? The reason is, as I said before, is like overdraw, you want to optimize. Even though you can do this stuff, there are issues. If you can optimize, because you know the engine or whatever, every step of the way, it really does help, right? Removing internal, so it's not only a, just because you're in billions of polygons doesn't mean we should always think, we should always think about optimization, okay? So again, the original was 1.47 million polygons on the left, and then the combined was 315,000 polygons, right? So again, the things that we have to think about these days are mesh sizes, both on disk and poly count. How many of you have been like, oh, this new game that 100 gig, and again, you still have to pull that data and do everything with it. So UVs to bring it home, right? So UVs, high polygon meshes, UVs, oh my God. This one was also a big one, but we figured it out. It's all good. UVing millions of polygons is no fun, but Houdini helps remove that, right? At this point now, it's a tool where you just run it through it, okay? So first thing I do is you just make a really coarse quad remesh of it. We want quads because you want nice straight lines. If it's going to move, you don't want none of this nonsense, okay? And then we take the seam of that, we go turn this UV seam in, split those polygons and turn it into a curve, okay? Then hey buddy, where are you going? Did that not work? Let's go back. No, the other way. Why isn't, oh, that one. Yeah, so we turn it into a seam, and then we project that seam back onto the high polygon model, and then you literally go, okay, I'm over here. So you get your curve, you get the point of the curve, and you go, where is the closest point on the high poly model? And then you put it there, and you go, the next curve, point on that curve, and you get that next point on the high polygon model, and then you go, great, find the shortest path, and it goes there. And the reason why you want to do that other than just project it on is because if you have quads, and it goes, here's a quad, the curve is here and on this top corner, if it is triangulated in the wrong way, it's like, I don't know how to get there, and you end up with all these things, right? These kinds of things are, I mean, once you kind of go, oh, that's what we need to do, it's really trivial to do that, right? So we find the path to them, we turn that group into a seam, and then we like unwrap it. And this thing, in 45 seconds, you just get like really, really nice clean UVs. And you can do this by hand. You can get your quad, the original dumbed down version, up at the top, and you can manually do your seams if you really want to, and then pipe it through. Or you can say, yeah, you do it, don't worry, it's a square, it's fine. Okay, and it's just, it works, it's awesome. And then there we just do the same thing, you know, get the brick, get the low poly, get your bricks, get the merged one, and then do the same vertex stuff. Or you could bake it to texture at this point. And then you put it in game. So you see, on the left-hand side is our block mesh, then our rough mesh, then the destruction version, and then the final game mesh on the right. And you can see, you know, we were able to step through that process. And the cool thing about this is over here is the last three, the rough mesh, the destruction, and final mesh, they're like really similar. Like you could even kind of go say, yeah, this is on a lower end platform, we're just gonna use that, right? Or it could be a fallback for like Nanite or something like that, right? But from an art direction, art process, level design working, it's really good to have these things that are so close to potentially what you want in there. All right, so there you go, that's them all put together. Apart from the obvious tiling seam, you can't really see a seam, right? And then here's some close-ups of that, right? Very, very quick to do. And then you can see here, so this is the actual network that we ran through. And it looks daunting, but it's not. It's like everything. And it's what I brought through, what I spoke about in the beginning, which was, if you think about what you know now compared to when you started, you know, it's the same. It's all you know, complex. So if you're looking at this and you're a bit intimidated, please don't be. We're going to a place where you need to do this stuff, in my opinion. And it'd be good if us tech artists didn't have to do it all. Thank you very much. Now, I have some resources on there. I have, I feel kind of embarrassed to do this, but I've got like I got a Gumroad page and a course on normals. So I found that a lot of people don't actually know deeply about normals and point normals and how they affect geometry. So I have a whole thing of like, this is a normal from a point right back to rebuilding tangent space normals in Houdini to understand what is that, and then like how to like bake and make good normals. I also have a thing on how to like build this entire like ruin kit, okay? Just FYI, it's 90 hours long. If you watch it once, I had to make it 3 times, okay? So just so you know. Once, can I do it? 2, to record it, then edit it, right? And then I feel kind of gross, it took a while, but for GCAP and for everybody here, it's like 25% off, so like, go nuts. And that's it. Oh, and also, Gameloft is hiring. At least I can keep my job now. Questions? Anybody? Oh, also the talk from my Unreal Fest, You're Probably Lighting Wrong, is also on there. So like, I think if you keep this resource, future talks, I'll just keep posting them into this like Dropbox thingo. Thank you. I blasted through that. That was good. Questions? Also, microphones. So if you want to go to a microphone, or you find a microphone if you want. Grab. Yeah.
Mm-hmm.
So, yeah, so that's part of the growing pipeline. We're having those conversations too. And I think a lot of it, like to me personally, is it could be potentially a Houdini Blender future, potentially to some degree. But also you have like Houdini for Unreal Engine is like, I think if you have Houdini, it's like, I think it's free or something like that. So there's things you could do there. Yeah, but again, going into this, as I was saying, it's more of like a methodology. So I'm sure at some point, some person will do this in geometry nodes. But how many of you saw the Blender Guru thing that he did on software? Like he did a poll or something like that, you know? And it was amazing. There was like, you know, thousands of people did it. And it turned out that the software that everybody likes is Houdini, Blender, and Unreal Engine, you know. And the thing with software, what you call it, not appreciation, but like, you know, it's like, oh, I have to use X program, but I hate my life, but I have to use it. But like with Houdini, people are like, you know, every like 0.5 release, you're like, oh my God, there's all this stuff. Like it like works, it doesn't break. I know that doesn't answer your question, but I think that there are, you have Houdini FX, which is like what the VFX studios use. We're using Houdini Core, which is like, you know, the one that studios can use. And that all stuff runs fine, right? Questions? Yes?
You mentioned Houdini. That was embarrassing. I'm not ready for that. I was just wondering.
It's okay, don't be shy.
Are there any tools similar to Houdini that you would recommend, perchance? Or is like Houdini its own like unique thing for procedural like modeling kind of work?
Did you say Houdini is a unique thing?
I was wondering, are there any alternatives that you would recommend if someone's finding it a bit difficult to like access Houdini for financial or whatever reason specifically?
Yeah. Well, there's Blender geometry nodes, you know, is a big one, I think. I've seen some psychopaths try and do this in Unreal or things like that. But there's also the thing is that if you're learning, you can get Houdini Apprentice for free. And if you're indie, it's like $150 a year or something like that. Like they really crank down the cost, you know. And then you just go to your studio and you go, look what I can do, and I need this. And then they go, oh my goodness, that'll save us so much time and energy and money. Okay, here you go.
Awesome, thank you.
No worries. Questions?
What's your thoughts on Houdini Engine? And utilizing the tools and just kind of like, you don't have to... you just don't always have to export everything out and, you know, you can just apply it under the blockout mesh with Unreal, or you can also just use the power of Houdini to do optimization inside the game engine, those kind of things.
Yeah, there's like, again, another point of this talk is like we need more of us to do this because there's so much things you can do. If you can go to the Houdini engine like page with all the you know, resources and tag your models to do this, they interface so incredibly well. My thing is, at this point in time, is when you do stuff in Unreal with Houdini and Houdini Engine, if you need to save something, it like spits out a mesh like in your content browser in like some weird place. And quite a lot of the time with this process, I'll like do the rough mesh and then save out that file. And then I'll do the destruction and then save out that file. And so you want to iterate at these stages, but now your content browser, you're spitting out all the stuff and you're like, I don't kind of like want this. It's like chaff stuff, you know? But so I think there can be some work there, or maybe I'm doing something wrong. If any of you have any ideas of that? Yeah, but then there's like loading all of that like stuff. Yeah. But that's a great point. Like that's the thing that I'm also trying to think about is like how do we just make it so that you can like just click and do that.
I was just going to say we used it for 45 levels.
Yeah.
800 folders, each of a folder.
Yeah.
Post one mesh within that.
Yeah.
And we have side effects like, can you resolve this because it's crazy? And they're like, oh, we don't know yet.
Well, there you go. So I think side effects need to start using Houdini and Unreal so we can.
Yeah, so I'm an educator. I work a lot with students. I loved your quote. If you can use ZBrush, you can figure this also out.
Oh, like
any other of those? Because I want to throw them at my students.
We have a sculptor at work, amazing sculptors, and they're like, ZBrush. Like, that's their job, and they're like, I hate that program. You know, like, so even the people who spend all day in there, it's like, you know, it's Stockholm syndrome. But not off the top of my head.
No, all right.
Thanks for the question. Yeah.
Quickly checking Houdini's website and their pricing scheme.
Mm-hmm.
Do they have a non-subscription based or like a permanent license? Because everything on there is rental and 1 to 2 years. And like, if I was to invest time into learning this program, I wouldn't want it to be taken away from me after 2 years. Is there a more permanent solution?
How much money do you have?
Not enough.
But also, like, but Maya does that, and Max does that, and it's unfortunate where we're in that world. Not that I'm aware of. Even, you know, you have a look at something like Rism UV. You're like, yeah, subscription. You know, I love the Blender people. They're like, Blender is free, and it's like, but the add-ons that you have to get for it, remortgage your house. Anyone else? In the back there.
Yeah, so a lot of the examples you've given are for static meshes, right?
Mm-hmm.
Any advice for doing the procedural modeling for more dynamic?
You talking about like fluids and things like that?
And deformables and even rigged and things?
So, yeah, so if it's deformable, like, so can you define deformable like, you know, like one of those like little things that you, thanks mate, those little things where you're like, no,
Yeah.
that was a bad example.
Like
what do you mean by
cloth.
deformable? Oh, like cloth.
Yeah.
So you could just get a static mesh and like sim it, right? Like let's just say a flag. You get your flag, you can sim it, and then you can take those vertices and bake them to a texture. So then you're using a vertex animated texture, and then you can play that over time. And there was a really cool thing that I did on a project where we wanted to like have thousands of characters or hundreds of characters. So we kind of made like a state tree where it's like running and then like bank left, bank right, and do all the things. And then in the shader as it was going, we're like, oh, you're in the blueprint. It's like, oh, you want to go left. It's like, do that alpha, you know, the lerp, and it would like bank left and bank right, you know. So yes, you can do that, except if you're doing deformable meshes and you're like, nanite, vertex animated textures. I think there is some people here that can help you out with that. Because I think like foliage with vertex animated textures and nanite is like stupidly expensive. I think they're going back to skeletons and things like that for that. Any questions? Yes, one over there.
Yeah, g'day. I was just a question about where you think the future, what the next step is. You sort of talked about going from sprites to 3D, and then you sort of went into more complex. Where do you feel is like, what's the next sort of like big leap?
Well, I think if you talk to Jensen Huang, who's the CEO of NVIDIA, they're like, everything will be generated, or, you know, it's like, nothing will be created. I'm not quite sure. There's a lot of interesting things with like, if you have a look at PlayStation dreams and what they've done with that technology, it's like, you know, pretty amazing, right? And you know, again, you have a look at what they're doing with Nanite, and other studios are doing things similar to that. It's like, dude, I don't know, I'm a tech artist, but I think it would be in the realm of, you know, a bit of all of it to some degree. And when you say future, do you mean like 10 years or, you know, longer? Because like mobile is such a big part, like such a big part of my job. You know, designers are like, oh, we want to do this, or art or whatever. I'm like, okay, but how do we get it to work on mobile, right? So, sorry, that's not a very good answer, but that's kind of where I'm at. Thanks. Anyone? Yes, one more over there.
This probably sounds like a dumb question.
No,
room
no
full
dumb
of
questions.
artists, but in video games, are walls that small really 300,000 polygons?
So that wall is 4 meters high.
Oh.
And yeah, it's 6 meters wide or 5 meters wide or something like that. But I think it's irrelevant of that at this point. It's more like the density, because if you're playing a first-person shooter and you're like, oh my god, look at the textures, you know, you're really mushing your face up there, you know, just so that you can get more sales. You kind of have to have the data in there. A thing that I think I glossed over was using dynamic tessellation. We done?
Still got 5 more minutes.
Oh, okay. Using dynamic tessellation, where, you know, again, you could take this stuff and then based on distance, you know, so like, oh, if you're like 5 meters, 10 meters away, like kind of turn that on and like, you know, blend that in and then not. So it's kind of like a mix and match of all of that. But no, currently a 3 by 4 meter wall is not 300,000 polygons. They're like 8 on mobile. Anyone more? Oh, there you go.
Yeah, just one more, and that's this was really aimed at sort of the realism side, and you're fitting things to kind of grid, right?
Not necessarily, right? It's more, as I said, it's more of a process. Like I'm sure, you know, I'm sure Fortnite will be pushing some polygons at some point. You know, it's really just it's resolving curved edges. It's, like also the biggest thing, like the thing that I find with this is like, what is one of the biggest pain points when you're creating stuff? You're like, okay, I have my model. It's like, now I gotta like make a low poly version. Now I gotta bake normal maps. Okay, I gotta bake it. Oh, this thing, the ray of the normal is like hitting this other piece and it's causing a thing. I need to create a cage, and then I need to make this. Like, I did none of that. Like that's the thing, right? You don't have to go. Okay, I'll go into a cave for a while and I'll come back like this, and they're like, no. Your lead's eating some pretentious fruit. Well, how about like, what about? Does that make sense? Yeah. I think there was a question over there.
Yeah, it's super cool that your system allows you to like seamlessly like create pieces that fit together like that.
Pardon?
Oh, it's very cool that your system allows you to create pieces that seamlessly fit together.
Right. Yes.
Do you, like, in terms of like creating like multiple variations of pieces, does your system allow you to like create multiple variations that still seamlessly fit together?
Absolutely.
Yeah.
Because once that one piece is done, when you go to the next stage to like punch out walls or like take bricks away or whatever, all you have to do is isolate the middle bricks and just keep the other ones there, and you can do whatever you want. You know, that's the power of it. You know, do we want to like a sewage pipe in here? You just yeet those out and do a Boolean and like, there you go, like move along citizen, right? Anyone else? No? All right. Thank you, everybody. Have a good GCAP.